Please check audio video okay or not. Hello. Hello. Yeah, let's start now. Dynamic programming. Right, so in this problem I will try to cover dynamic programming, right, as much as I can, right. Let me start the dynamic programming. In this class I will try to complete as much as I can about dynamic programming. Yeah, I am starting now. See, just I will try to finish it off as much as I can so that everyone can understand, right. See, dynamic programming, right, basics, what is needed. In one problem only I will explain. So to explain the dynamic programming, I am selecting Fibonacci. Right, to explain the dynamic programming, I am selecting Fibonacci series. There are so many applications of dynamic programming, right. Let me select one of the application, that is the Fibonacci series, right. So let's see how it will work out. So I am starting. So can you help me now? Fibonacci series, I think everyone know. Fibonacci series, I think everyone know. See this one, n, Fibonacci of n. First let me write the series first. First let me explain what is Fibonacci first. So those people who are watching, right, follow properly. Those people who are watching, follow properly. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, n value 0, Fibonacci 0 is 0, n value 1, Fibonacci 1 is 1, till now normal. N value 0, Fibonacci 0 is 0, n value 1, Fibonacci 1 is 1, this is nothing, right, until now nothing happened. Now see, from now onwards, Fibonacci of, listen, n value 2, Fibonacci of 2 is equal to sum of previous two numbers, 1. N value 3, previous, right, n value 3, Fibonacci 3 is equal to sum of previous two numbers, 2. N value 4, right, Fibonacci of 4 is sum of previous two numbers, 3. Sum of previous two numbers, 5. Sum of previous two numbers, 8. Sum of previous two numbers, 13. Sum of previous two number, 21. Before that, right, 34. Check one time. Check one time if anything wrong. To explain dynamic programming, I selected the Fibonacci series, right, I written also, right. So this is the way how to find out Fibonacci of any value. So those people who are saying that, sir, I got it, those people who are saying that, sir, I got Fibonacci series, let me ask you one small line. If you really okay, what is the Fibonacci of 100? Fibonacci of 100 is equal to sum of previous two number, Fibonacci of 99 plus Fibonacci of 98. If you really okay whatever I done till now, if you really okay, so Fibonacci of 100 is equal to, right, Fibonacci of previous two numbers, right, that is also okay, right. If you are really comfortable, let's see this also. Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Right, fine. I think till now I am making sense. I think till now I think all the people are with me, right, fine. Yeah, perfect, everything fine, everything fine. So please check if anyone till doubt. If anyone having till doubt, please let me know. If you okay with this, can you help me now? Similarly, there is a one joke also in the computer science. There is a one joke also in computer science, that is Fibonacci soup is equal to like sweet corn soup, tomato soup, right? Like that. There are so many soups are there. Tomato soup, Fibonacci soup, that's right. So, like so many soups are there, you know, like Fibonacci soup also. Fibonacci soup is equal to, in your house yesterday one soup is made, yesterday's soup, and day before yesterday's soup, day before yesterday's soup. Yesterday in your house some soup is made, day before yesterday also one soup is made, just mix them, little bit left out, mix them. That soup name is called Fibonacci soup. Yesterday in your house some soup is made, little bit left out. Day before yesterday one soup is made, little bit left out, mix them, right? That soup is called Fibonacci soup. I don't know whether it is tasty or not. Really, I don't know whether it is tasty or not. Please, those people who don't know about this, you can try one time. You please let me know the taste. I didn't try it till now. So I really don't have any idea, right? What is the taste of that? If anyone interested, you please try. If you really love it, right? Please let me know. I will also try. Right? Please do that. Right? Please do that. Yeah, if you all people are okay, I can go to the next one. If you all people are okay, I can go to the next one. Yesterday in your house some soup is made, day before yesterday one more soup is made, little bit left out, mix both of them, that soup name is called Fibonacci soup. I don't know is it tasty or not, you can try once and you please let me know. Right, let's go to next. Let's go to next. Because of you are really comfortable, let me write the program. Fibonacci of n. Let me write the program. Fibonacci of n. Right? So because of you are okay with the problem, I am writing the program. Fibonacci of n. Right? See the program. If n is equal to 0 or n is equal to 1. If n value 0 or n value 1, you know this program starting two values you have to give. First two values you have to give, remaining all will come by adding previous two. First two things should be given. Fibonacci of 0 is 0, Fibonacci of 1 is 1. That is the thing what you have to do. If n is 0 or n is 1, return. If n is 0 or n is 1, return n. Else, return n. If n is 0 or n is 1, right, return n. Else, right, let me write now, else. So what is the answer? Else, I think if you observe clearly, else, right. So return Fibonacci of n minus 1 plus Fibonacci of n minus 2. End of the else, end of the program. End of the program. Please check. This is the program. So with the help of one example, I will show what the total dynamic programming is. With the help of one problem, I will show what the total dynamic programming is. Please follow me in this entire class. I will try to explain what is the dynamic programming with the help of this problem. Check anyone having any doubt. Till now. Anyone having any doubt? See, from starting onwards, if you observe, see this one. Dynamic programming I started, so I took one example, right? To explain that dynamic programming, I took one example, Fibonacci series. First I am explaining what is Fibonacci series, I am explaining, right? I think I drawn the table. So n value 0, Fibonacci of 0 is 0, n value 1, Fibonacci of 1 is 1, n value 2, right? Fibonacci of 2 is previous 2 number, Fibonacci of 3 is previous 2 number, and so on. So Fibonacci of 100 is Fibonacci of 99 plus 98, Fibonacci of n is Fibonacci of n minus 1 plus n minus 2. Fibonacci soup is equal to yesterday's soup plus day before yesterday's soup, right? This is for joke, right? This is for joke. Some people may take serious and they may try. No, don't do that. You will get the diseases. Some people are so serious about this soup. Don't try this, right? You will get health problems. Please don't try, right? Fine. Next one, based on that story I written the program also. This is the program. Based on this one I written the program also, right? If you okay till now, we can go to the further steps. If you okay till now, we can go to the further step. Anyone who is having doubt, let me know. Till now. N value 0 or n value 1, Fibonacci of n is n. Otherwise, Fibonacci of n minus 1, Fibonacci of n minus 2, right? Add them and return. Someone is asking, sir, in DP it is compulsory to add recursion. Yeah, DP means recursion only. Right? DP means recursion only, but you may write equivalent non-recursive program also. Actually, DP means recursion. You may write non-recursive program. After writing everything, if you feel writing a non-recursive program easy, you can write. Right? Fine. DP means recursion. Right? Let's start this. So I think I have a recursive program in front of me. Let me analyze. How to find out recursive program time complexity? Let me write. Listen everyone now. Let T of n be the time complexity of above problem or above program. Let T of n be the time complexity of above program. So this program time complexity T of n is assume. So how to find out? Very simple. Recursive program time complexity, if you want to find out, write recurrence relation. Recursive program time complexity, if you want to find out, write recurrence relation. How? Very simple. F of n time complexity Tn. F of n time complexity Tn. See, here no loop, nothing. So time complexity here constant. Here recursion. Recursion is recursion. F of n is Tn, F of n minus 1, Tn minus 1. F of n minus 2, Tn minus 2. Right? After getting this answer, this much time required. To get this answer, this much time required. After getting both the answer, you have to add them, which will take constant. So T of n is equal to constant if n is equal to 0 or n is equal to 1. Otherwise, answer is Tn minus 1, Tn minus 2 plus C. If n greater than 1, careful. If you want to find out recursive program time complexity, you should know how to write recurrence relation. Right? F of n time complexity Tn, if you believe that is true, F of n minus 1 time complexity T of n minus 1. F of n minus 2 time complexity T of n minus 2. Please careful. If you believe this will take Tn, compulsory you have to believe F of n minus 1 Tn minus 1, F of n minus 2 Tn minus 2. Right? After getting both, addition will take constant time. So if condition will take constant, else condition will take Tn minus 1 Tn minus 2 plus C. Right? So recursive program time complexity, if you want to calculate, please remember you should write recurrence relation for a time. You should write recurrence relation for a time. If you can do that, you will get the time complexity. Anyone having any doubt till now, let me know in the comment section, so that I will explain your doubts. I will go further. So that I will explain, right? I will explain your doubts. I will go further. Do you have any doubts till now? Do you have any doubts till now? Right? I am repeating. It is a very, very important one. Recursive program time complexity. Recursive program time complexity. If you want to find out recursive program time complexity, if you want to find out, write recurrence relation for time. Some people are thinking that recurrence relation for the given recursive program one way. No. Recursive program is given, you can write time complexity purpose recurrence relation. Recursive program is given, you can write recurrence relation for time. You can write recurrence relation for value. You can write recurrence relation for whatever you wish. Right? Some people, right? Not some people, most of the people don't know. Most of the people don't know for the given recursive program many recurrence relations possible. They don't know this. They don't know this. This is the problem. This is the problem, right? Some people without knowing this, they will teach. For the given recursive program, many recurrence relations are possible. But many people are thinking that only one possible. No, one recursive program, many recurrence relations possible. How? For the given recursive program, time complexity purpose, write properly. Right? One time complexity recurrence relation you will get. Right? Next one, output purpose you write, one recurrence relation you will get. Addition purpose you write, one recurrence relation you will get. Multiplication purpose you write, one recurrence relation you will get. For the given recursive program, recurrence relations are many. What you want, you write properly. What you want, you write properly. So, for the given recursive program, if you want to find out time complexity, write recurrence relation for time. I written the recurrence relation for time. It may be difficult, but when you practice more problem, you will get clarity. When you practice more problem, you will get clarity. How to write recurrence relation? That's what I am saying. That's what I am saying. Right? If you practice more, you will get. And one more thing is, right? Before going further, if anyone having small doubt also, before going further, let me give one small thing. Listen, everyone. Let me give one small thing. Everyone listen. Tomorrow in Unacademy, tomorrow I am starting Algo DS. Algo and DS started already, but tomorrow onwards recursion will start. Algo DS I already started. Right? 4 or 5 lectures are over. They are already recorded. You can watch them. No problem. Right? Already completed thing and tomorrow's thing, no relation at all. Comfortably you can follow. Recording already there. It will take 1 or 2 days to watch them. Right? So if you join today, tomorrow you will get total Algo DS. It is almost like, right, 45 days course. Algo DS is, right, combinedly 45 days course. If you are, this will be useful if you can get this Algo DS course properly, if you can get, you will get the GATE exam also, you will get the placements also, you will get the MNC companies also, you will get the PSUs also. Many ways it is useful. Tomorrow it is starting, right? Recursion is starting, right? 7 AM to 10 AM. If possible, you can attend. Because in one class, saying the total Algo DS may not be possible. But I will try to cover that, right, dynamic programming in today's class. With the help of one example, I want to explain dynamic programming. 7 AM to 10 AM every day morning 7 AM to 10 AM. So 45 days if you attend Algo DS, you will get A to Z. With that knowledge, you will get any job. You will get the job in any company through experience. I am saying. I taught approximately 10 lakh students till now. I taught 10 lakh students approximately. Join in Unacademy, one nice offer also going on, 24% off. You take any subscription, 24% off will be there. 6 months if you take subscription of plus class, you have to pay only this much. 9 months, this one. 12 months, this one. 18 months, this one. 24 months, this one. You can go for iconic also, right? 6 months, 9 months, 12 months, 18 months, 24 months. use referral code ReddySir to get the discount. 24%, and one more, this offer is valid July 29. My suggestion is please join today. My suggestion is this: if you are not serious, you no need to join. If you are serious about your career, you can join. Definitely it is going to be positive thing to you. If you are serious, you join. If you are not serious, you no need to join, not required. Now go here. See this one, nothing can stop you from chasing your GATE and ESE dream, right? So you can start with no cost EMI, 0% interest. You can start with EMI also. Within 2 hours it will approve. Minimal paperwork, flexible tenures. If you want to join Unacademy supporting you like anything, 24% offer going on, and one more, no cost EMI, 0% interest EMI. Price hike is there from this month end onwards. Those people who are serious, using this code, join as soon as possible. And one more, those people who want printed notes, those people who want the notes, those people who want printed notes, right? So buy now, 20% off. Use the referral code ReddySir. Right? Fine. You can go for iconic also. You can go plus also. Whatever you want, you can do. So if you go for plus, you will get these 4 advantages. Iconic, many advantages you will get. My personal opinion is go for iconic. Go for iconic. That is my personal opinion. Right? And one more thing, right? So you can join in this batch, right? You can join in this batch. You can attend algo. Data structures, programming, TOC, compiler design, computer network. These are the things which I am teaching. Very soon I will start some more subjects also. As of now, I completed these subjects. These are the 2 things I already completed. And one more live batch also going on. Some batches I already completed. Recording also there, live also there for all these subjects. Right? Not only me, some more, right? Some more great faculties are there. They will definitely help you in the remaining subjects. Right? Fine. Let's go to next one. If you go for the EMI option plus 24 months per month, you have to pay this much. 18 months per month you have to pay, 12 months, 9 months per month this much, 6 months per month this much. Use the referral code ReddySir. So you can go for the iconic also, 12 months, 24 months, 18 months, 12 months, 9 months, 6 months. I hope this will be useful to you. Right, let's go to our actual story. If you want to find out recursive program time complexity, write recurrence relation. I already written, this is the recurrence relation. T of n is equal to T n minus 1 T n minus 2 plus C. It is the recurrence relation for a time. This is the thing what I written. The next one is how to find out time. Nothing. Just to solve this one. Solve this recurrence relation. If you solve this one, some people are asking, sir, how to solve? Remember, any recurrence relation contain more than one function call. You have to go for recursive tree method. Solve this recurrence relation using recursive tree method. Right? There are so many methods are there to solve the recurrence relation. If any recurrence relation contain more than one function call, right, you can solve that recurrence relation using recursive tree method. How recursive tree method? Let me try. See this one, n, right, left is n minus 1, right, minus 4. Again, right, this level C from this side, this level C from this side. Total is 2C. I think if you observe clearly, first level C, next level 2C, next level if you observe clearly 2 square C. If you go further, everyone will bring 2 people. Right? It will goes to 2 cube C. It will continue, right? If you observe clearly, n is here n minus 1, here n minus 2, here n minus 3. If you continue like this one, it will goes to until 1. That means total number of levels, if you observe, total number of levels, if you observe, total number of levels, if you observe, n levels, right? Total number of levels, if you observe, n levels. So n level, right? GP series you will get. So finally, if you write all of them, Tn is less than or equal to 2 power 0c, 2 power 1c, 2 square c, and so on, 2 power nc. If you solve that one using GP series, c outside, 2 power 0, 2 power 1, and so on, 2 power n minus 1, or 2 power n. If you want, you can write 2 power n, because difference by only constant, no problem, right? Next one. So this one can be written as c into, right? Solve this GP series, you will get 2 power n. Answer is big O of 2 power n. So time complexity of the program which we written is 2 power n. Time complexity of the program which we written 2 power n, right? Careful. So we done approximately n times we done. See this one, see this, n times we done. So how many times you done? So n times you done, you only saying n times you done, right? This is the n time. N times you done. This is called this n times whatever you done. This is called stack space. This is called stack space, right? In this recursive tree, how many levels are there? That is called stack space, right? After solving whatever you got, that is called time complexity. I hope till now you are comfortable. Please go and check from starting. Till now you are comfortable. It is a recursive program. How to find out recursive program? Time complexity. Write recurrence relation for time. See this one. Write recurrence relation for time complexity. I written. The only thing is how to write recurrence relation for time complexity. That may be difficult, but if you practice more problem, you will get more clarity. That's what we will do in ongoing algorithm data structure class. That's what we will do in ongoing algorithm data structure class. Right? Let T of n be the time complexity of above program. So T of n is this. When you have T of n, right, recurrence relation, how to solve that recurrence relation? You can solve like this. You can solve this recurrence relation, right? After solving whatever you got, that is the time complexity. Next one, how many levels are there in this recursive tree? That is called stack space. N levels are there. So stack space is n. Let me write. Stack space n, which is also called space complexity. Stack space is n. Time complexity 2 power n. Let me know if anyone having doubts. Let me know if anyone having doubt. Satyam is saying that if there is no recursion, then there is no dynamic programming. No, it's not like that, right? Normally dynamic programming is recursion. What is the reason? You will see now. Satyam, you will see it is a very nice doubt. For every recursion, non-recursion there. For every non-recursion, also recursion there, right? For every recursion, non-recursion there. For every non-recursion, so both are possible from both the side. Some may be easy, some may be tough, but both are possible. Sir, DP recursion program easy? Yeah, that is the reason for that. DP recursive program is easy. DP recursive programs are easy. How to write recurrence relation? It may be tricky, but if you practice, you will get. It may be tricky, but if you practice, you will get. Check anyone having any doubt. Any doubts? Someone is saying, can I start programming from scratch for GATE 2023? Yes, you can start. You can start. But you should be quick enough. You should be fast. You should work 10 hours per day. Sean, you should work 10 hours per day. You should work 10 hours per day. You should work 10 hours per day. You should do lot of hard work. Then everything possible. Then everything possible. So if you are okay till now, I can proceed to the next one. If you are okay till now, I can proceed to further. Can I go further? Those people who will say go further, please type yes. Can I go further? Those people who will say go further, say yes. Those people who are having doubt, you can ask doubt. Those people who have doubt, right, they can say they can ask their doubts. If you have doubt, you can ask. If you have doubt, you can ask. Sachin saying no. Sachin, say what doubt you have. Sachin, say what doubt you have. You are saying no, I am able to see. Can you type in the comments what doubt you have? Arey Sachin, say man, what doubt you have? If you have doubt, you say, I will explain the doubt. If doubt is not there, if doubt not there, say yes, I will proceed further. Yeah, let's go further. Let's go further. Right? Write the recurrence relation, solve it. So time complexity purpose, write recurrence relation. Please remember, this is the biggest mistake what students are doing. This is the biggest mistake what students are doing. Right? They will write the recurrence relation for value. Right? After solving the value recurrence relation, you will get value. There are some students are there, they will write the recurrence relation for value. Right? They will solve it, they will finally get value. Value recurrence relation purpose, if you write, if you solve it, you will get value. Time complexity recurrence relation, if you write, if you solve it, you will get time. What purpose you written, that will come. If you written for value, if you solve it, you will get value. If you written for the right time complexity, if you solve it, you will get time complexity. If you written the recurrence relation for additions, after solving it, you will get additions. If you written the recurrence relation for multiplications, after solving it, you will get multiplications. Please be careful. The problem with the students is they will write for something, they will give answer for something else. Whatever you want, write for that, solve it, you will get it. Right? I think this line is confusing to you, but it is truth. What purpose you want to write the recurrence relation, you write, you solve it, you will get it. If you write for value, right, after solving you don't get time complexity. If you want time complexity, write the recurrence relation for time. That's what I done. See, this is the recurrence relation for time. This is the recurrence relation for time. It is the recurrence relation for time. Recurrence relation for time complexity. I written, you solve it using, see, more than one function call. Then go for recursive tree method. Only one function call, go to substitution method. Right? If recurrence relation is look like divide and conquer format, go for master theorem. If recurrence relation look like divide and conquer, go for master theorem, only one function call, go to substitution method, more than one function call, go to substitution method, go to recursive tree method. I am repeating once again, more than one function call in the recurrence relation, go to tree method, recursive tree method, only one function call, substitution method. If recurrence relation in the form of divide and conquer format, master theorem. So more than one function call, recursive tree method you go, I done. See, first level cost is C, second level cost is 2C, third level cost to 2 square C, fourth level cost to 2 cube C, and so on. N levels are there. See, n levels are there. So 2 power n C. If you solve all of them, you will get 2 power n. Time complexity 2 power n. How many levels are there in the tree? That is called stack space n. If you okay till now, I will go to dynamic programming. Till now dynamic programming is not done. If you are okay, I will go to dynamic programming. If you are okay, I will go to dynamic programming. Until now dynamic programming is not done. It is the starting of dynamic programming. It is starting of dynamic programming. Until now you are okay, I will go to dynamic programming. Until now you are okay, I will go to dynamic programming. Please let me know. Please let me know. Yeah, let me start now. Everything ready? Let me start. So dynamic programming. Everyone listen. Using dynamic programming. Everyone using dynamic programming. Using dynamic programming. How? Let me explain. Very simple. Let me explain. Can you help me now? Fibonacci of 6 is nothing but Fibonacci of 5 plus Fibonacci of 4. Fibonacci of 6 if you want to calculate, Fibonacci of 5, Fibonacci of 4. Fibonacci of 6 if I want to calculate, Fibonacci of 5, Fibonacci of 4. Next one, Fibonacci of 5 if I want to calculate, Fibonacci of 4, Fibonacci of 3, previous two numbers. Fibonacci of 4 if you want to calculate, Fibonacci of 3, Fibonacci of 2. Fibonacci of 3 if you want to compute, Fibonacci of 2, Fibonacci of 1. Fibonacci of 2 if you want to calculate, Fibonacci of 1, Fibonacci of 0. Fibonacci of 2 if you want to calculate, Fibonacci of 1, Fibonacci of 0. Fibonacci of 3 if you want to calculate, Fibonacci of 2, Fibonacci of 1. Fibonacci of 2 if you want to calculate, Fibonacci of 1, Fibonacci of 0. Until termination condition, please keep on substitute. Fibonacci of 4 if you want to calculate, Fibonacci of 3, Fibonacci of 2. Fibonacci of 3 is Fibonacci of 2, Fibonacci of 1. Fibonacci of 2 is Fibonacci of 1, Fibonacci of 0. Fibonacci of 2 is Fibonacci of 1, Fibonacci of 0. Please check all are substituted or not. If anyone having small doubt also, can you see this one? 6 becomes 5, 5 becomes 4, 4 becomes 3, 3 becomes 2, 2 becomes 1. What is the meaning? N level. 6 given 6 level, n given n level, n level tree. 6 given 6 level tree, n given n level tree. 6 given 6 level tree, n given n level tree. So, and one more, because of these many function calls are there, listen, because of these 6 level binary tree, listen, 6 level binary tree, if you observe clearly, 6 level binary tree, if you observe clearly, right, 2 power 6 function calls are there. 6 level binary tree, binary tree means every level 2 people, something like that. 6 level, 2 power 6 function calls are there. If at all n level binary tree, 2 power n function calls are there. 6 level binary tree, right, 2 power 6 function call. Total if you count, listen, if you count all these total people, 2 power n function calls are there. all the people count. Almost 2 power n function calls are there. N value 6, 2 power 6, almost 64. Almost 64 function calls are there. 64 function calls are there. So that is the reason time complexity became 2 power n. Right? This tree contains n level. It's a binary tree. Everywhere 2 possibilities, like that 6 levels. 2 power 6 function call means 2 power n function call. That is the reason time complexity became 2 power n. That is the reason time complexity became 2 power n. That is the reason for that. That is the reason time complexity became 2 power n. Right? Now listen. Everyone listen. Everyone listen here. Everyone listen. That is the reason time complexity became 2 power n. Because total function calls became 2 power n. Time complexity became 2 power n because of that is the main reason. If anyone asks you from today onwards, Fibonacci series time complexity 2 power n, why? You say number of function call almost 2 power n. Number of function calls are almost 2 power n. Right? That is the reason time complexity became 2 power n. Right? So if anyone asks you time complexity why 2 power n for the Fibonacci, simply say one thing. Number of function calls for 6 people, if I give n value 6, 2 power 6 function calls are there. If I give n 2 power n function calls are there, time complexity became 2 power n because 2 power n function calls. Right? Fine. So let me adjust the camera a little bit. Yeah, is camera okay? Can you check? Varun asking, can I follow new one or old one? Varun, anything is okay. Varun, anything is okay. Arey, Akhtar, is it okay? Akhtar, is it okay? Akhtar, is it okay? Right, perfect. Yeah, let me continue this. Let me continue. So if anyone asks you from today onwards, Fibonacci time complexity 2 power n, what is the reason? Can you say what is the answer you are going to give? Fibonacci of n time complexity 2 power n, what is the reason? If anyone asks you, what you say is Fibonacci of n will generate n level tree, which is the binary tree. N level tree, which is the binary tree. Indication that n level everywhere 2 people, so 2 power n function calls came. Every function call will take constant time, 2 power n function call 2 power n time. You can say like that. If anyone asks you Fibonacci of n why it is taking 2 power n, you simply say Fibonacci of n will generate n level binary tree. N level binary tree it will. So n level binary tree, everywhere 2 children are there. N level total nodes are 2 power n, means total function calls are 2 power n. Every function call will take constant time, 2 power n into constant 2 power n. Just say like that. Okay, that is the reason Fibonacci of n time complexity 2 power n. If anyone asks you Fibonacci of n, what is the space complexity? If anyone asks you Fibonacci of n space complexity n, how? Simply say n level tree. So space complexity n. Fibonacci of n contain n level tree, so space complexity n. If anyone asks you time complexity 2 power n, why? Simply say n level tree, it is a binary tree, everywhere 2 children, so 2 power n function call. Every function call is constant, so 2 power n time. Okay, until now everyone is okay. Okay. Now can you listen everyone? It is the highlight of today's class. Can you listen everyone? It is the highlight of today's class. That the highlight line of today's class, if you observe, right? In this tree, anyone repeating. This is the highlight of today's class. This is the major line. If you see so many function calls, 2 power n function calls are there, okay. If you see properly, anyone repeating, can you check? In this tree, anyone repeating. This is the main line. Those people who are sleeping, please give answer and sleep. Those people who are sleeping, please give answer and sleep. Those people who are sleeping, please give answer and sleep. In this tree, anyone repeating. In this tree, any function call repeating. Can you check one time? In this tree, anyone repeating. Hello, sleeping people, please say. In this tree, anyone repeating. I think if you observe clearly in this tree, listen, if you observe clearly in this tree, right, see this one, f of 4, one time, f of 4 here also, see, 2 times there, right? If you observe this tree properly, f of 4 here, f of 4 here also, right? I think f of 4 repeating 2 times. And if you observe f of 3 here, f of 3 here, f of 3 here, so f of 3 is 3 times. I think if you see f of 2 many time, f of 2 many time is there, many times, not one time, 2 time, many time. F of 2 is many time. So what I want to say is, listen, why this program taking this much time? The reason is many people are repeating. Why this program taking a lot of time is many people repeating. Please careful. This program taking a lot of time. The reason is many people are repeating. Not one person, 2 person. Many people repeating. So what I want to say indirectly, directly is, listen everyone now. What I want to say indirectly, directly, when our programming is started approximately 50 years back. Not 1 year, 2 year, 50 years back programming is started. Initial days there is no recursion. So 50 years back it is started. Initial programming languages don't have recursion. So one of the MIT professor got one idea, right? Every time f function calling g function calling k function, so one function calling another function. One of the MIT professor got idea like one function calling another function, why can't it will call itself? Why can't a function calling itself every time calling other function? Why can't it call itself? So with that intention, right, recursion is started. So a function can call itself also. Until that day, right, a function cannot call itself. Every time function f calling g calling h, like that. But from that day onwards, because of that MIT faculty, why can't a function call itself? Right, they kept one name also, recursion. So first to 10 years no recursion, right? From the 11th year onwards recursion started. So every program contained recursion and all, everyone celebrating also. Recursion came, greatest innovation, something like that. Everyone so happy, right? First to 10 years no recursion, 11th year onwards recursion started, everyone happy with recursion, so all are celebrating with the recursion. Then one day what happened is, one of the MIT professor from CSE branch, he got this kind of idea. Array, this Fibonacci taking 2 power n time, this program looking like very small program, it is taking this much time. What is the reason? What is the root cause for this? So they took one example, they draw one tree like this, they started observing. They got to know that many function calls are repeating. So he got to know what the major cause for all this problem. Why most of the programs contain, most of the recursive program contain lot of time. He got the observation. What is that? Most of the recursive programs are suffering with one disease. That disease name is called corona. No, not corona. Right? I am repeating once again. Most of the recursive programs are suffering with one disease. That disease name is called overlapping subproblem. Not corona, overlapping subproblem. Please careful. So that MIT faculty identified that most of the recursive programs are suffering with one disease, that is called overlapping subproblem. Means functions are calling himself again and again. Means what does it mean? Same thing repeating. See, F4 is came many times. If I take F6, so these many repetitions are there. If I take F50, you can't imagine how many repetitions are there. So because of that reason, dynamic programming is started. Because of that reason, dynamic programming started. What is the dynamic programming? A function calling itself, right? F of 4 is calling, F of 4 is coming many times. What dynamic programming is saying is, if F of 4 is coming many times, I will do one time only. F of 4, right? Fibonacci, right? Normal recursive program saying that F of 4 is coming 4 times, I will execute 4 times. But dynamic programming is saying that F of 4 is coming 4 times, I will do one time only. So remember, in dynamic programming, every person cannot be done every time. Every person will be done one time. In the normal programming, every person will be done every time. In the dynamic programming, every person will be done one time. Some people are asking, sir, if you do one time, one more time came, what you do, right? Because of one time I done, one more time will come, existing value I will utilize it. I am repeating once again. Dynamic programming, every function cannot be computed every time. Every function will be computed only once. Next question, suppose same person coming again, if you don't want to compute, how will you get the value? I already computed, I will reuse it. In dynamic programming, first time you will compute, you will store somewhere, whenever same person come back again, reuse it. In the normal programming, every time compute. In the dynamic programming, compute one time, reuse it. In the dynamic programming, compute one time, reuse it. In the normal programming, compute every time. Compute every time. Sachin said already, just right, Sachin said already, can calculate it once and use that result at many places. Yes, exactly. In the case of dynamic programming, right, a function will be computed only once. It will be reused further. In the case of normal programming, right, how many times he is repeating, those many times you will solve. Dynamic programming, 10 times he is repeating. 9, right, one time you will do, 9 times you will reuse. This is the only difference. This is the only difference. Other than that, nothing is there. Very simple one. If you use common sense, that is called dynamic programming. If you use common sense, right, that is called, while writing programming, if you use common sense, that is called dynamic programming. If you don't use common sense, that is the normal programming. Normal programming, a person repeated 25 times. 25 times you have to calculate. Dynamic programming, 25 times a person is repeating. One time do reuse it. One time do reuse it, right? That's it. Now listen. If you observe clearly, right, f of 1 is coming many times, f of 6 is coming many times, f of 4 is coming many times. Now listen. See this one. See everyone. In dynamic programming, we we will compute in dynamic programming, we will compute only distinct function calls. Distinct function call. In dynamic programming, we will compute only distinct function call. Distinct only, not everyone, only distinct. Different people only we will calculate, not same person many time. In the normal programming, everyone, every time. Dynamic programming, only distinct people. Can you help me? Can you help me? In Fibonacci of 6, while calculating distinct people, how many? First of all, Fibonacci of 6 himself, Fibonacci of 5, distinct only. Fibonacci of 4 one time, Fibonacci of 3 one time, Fibonacci of 2 one time, Fibonacci of 0 one time. What is the meaning? Fibonacci of 6 distinct functions if you calculate, I think 6 to 0, 6 plus 1 distinct function call. If at all Fibonacci of n, if you use dynamic programming, how many distinct function call? N plus 1 distinct function calls. N plus 1 distinct function calls. Dynamic programming will compute only distinct function call. Normal programming will compute everyone every time. If you compute everyone every time, 2 power n. If you compute only distinct people, n plus 1. Distinct people are n plus 1, everyone every time is 2 power n. Let me write that also. Fibonacci of n, if you compute everyone every time, 2 power n. If you compute only distinct, n plus 1. Right? Everyone, see this one, everyone, every time, 2 power n. Right? Everyone one time only, means distinct people, n plus 1. Right? If n plus 1 distinct function call, what will be the time complexity? N plus 1 distinct function call time complexity, right? N plus 1 means big O of n. Time complexity big O of n. Please careful. How many function call? That much time. How many function call? That much time. Right? If you do normal programming, 2 power n function call, 2 power n time. If you use dynamic programming, distinct function calls how many? N. Right? N plus 1 means n. So n over. Right? Please careful. Please careful. Normal programming, everyone every time. Everyone means how many? 2 power n. Everyone every time, 2 power n. In the dynamic programming, everyone one time, one time. Same person coming again, don't compute. Same person coming again, don't compute. Same person coming again, don't compute. Everyone every time, that is called normal programming. Everyone one time, that is called dynamic programming. If anyone having any doubt, let me know. Sir, I have this doubt. You ask me, I will help you. If anyone having small doubt also, you ask me, I will help you. Someone is saying that log n possible by matrix exponentiation, right? Maybe that is possible, right? Until here, using dynamic programming, this much. Himanshu, right? Using dynamic programming, this much. Using dynamic programming, this much. Yeah, whatever you are saying, yeah, I seen somewhere that is also possible, right? Log n. Please check once again, right? Using dynamic programming until here. So, but the interesting thing about this one is, I think one point I want to say that also. Please listen. In dynamic programming, as soon as you compute, you have to store. In dynamic programming, as soon as you compute, you have to store. Can you help me now? How many distinct function call? N plus 1 distinct function call. N plus 1 distinct function call. So, N plus 1 table required. As soon as you compute, you have to store. One array you take, as soon as you compute, you store. right? Let me write now. Fibonacci of 0. A of 0 will store Fibonacci of 0. A of 1 will take Fibonacci of 1. A of 2 will take Fibonacci of 2, and so on, and so on, right? A of n will take Fibonacci of n. In dynamic programming, as soon as you compute, you have to take a table. You have to take one table, right? You have to take one table. Can you see this table size is, right? How many distinct function calls are there? Those many. How many distinct function calls are there? Those many. And one more thing is, listen, normal programming also recursion. Dynamic programming also recursion. The only thing is, in the normal programming, same person will be done many times. Here, same person will be done one time. That is the only difference. Means, he is also using recursion. Normal programming also using recursion. When you say using recursion, stack space, let me write now. When you say using recursion, stack space is equal to, because of you are using recursion, same recursion, everything same, n for the stack space. Let me write now. Extra space is stack space, extra space is stack space, and one more thing also there. What is the one more extra? Table, because of dynamic programming, table, right? Stack space is same stack n, both are recursion, with dynamic programming, without dynamic programming, both are recursions only, both will take same stack space, but one more table also added. Table contain n plus 1 distinct function called n plus 1. If you add overall, it became n. So what I want to say is, time previously 2 power n using dynamic programming only n. Time previously 2 power n using dynamic programming. So this is not using dynamic programming, leave it. Time complexity previously 2 power n, now only n. What does it mean? Time decreased a lot, space little bit increased. Because of table, space is increased. But overall, if you see asymptotically n only. Overall, if you see asymptotically n only. Some people are asking real life of real life of DP, right? Your life is, right? Real life is DP only. Your life itself is dynamic programming, because in the real life, if you observe, if you have already pen, why you buy pen again? If you have already pen, why you buy pen again? Already pen is there, you will buy pen again? No. You have already notebook, why you buy again? Right? Am I right or not? Real life is dynamic programming. Already there, why you do again? Common sense. That is the reason all CSC people like dynamic programming. That is the major reason. Already there, why are you doing again? The only little bit drawback of dynamic programming is, as soon as you compute, you have to store. As soon as you compute, you have to store. The only drawback of dynamic programming, as soon as you compute, you will store. So some space is wasting. But a lot of time is saving. It doesn't mean that for every problem you will apply dynamic programming. There are some problems are there where no sub problem will repeat. Some people thinking that if that is the case, every problem I will apply dynamic programming. No, there are some problem nothing will repeat. If nothing will repeat, if you compute and if you store, nothing is repeating, what is the use of computing and storing? Unnecessarily space will waste. Right? Some people are asking, sir, any problem is there which don't repeat at all? Yes, there. That is called NP complete, NP hard. In the NP hard, NP complete, nothing will repeat, because they are complex problems. You cannot do any optimization. So those people who are watching, if you have doubt, please let me know. Those people who are watching, if you have any doubt, please let me know. Himanshu, do you have any doubt? Himanshu, do you have any doubt? Please check. Anyone having any doubt? Yeah, I think Vikas asking why can't we apply DP on NPC? So the purpose of DP is when you apply DP, if you want to apply DP, right, when recursion is going on, some people should repeat. Repetition should be huge. Lot of repetition, then dynamic programming is a great idea. Lot of repetition, dynamic programming is a great idea. If no repetitions, dynamic programming is the worst idea. No, listen everyone now. If no repetition, dynamic programming is the worst idea. Repetitions are there, then only dynamic programming great. If you want to apply dynamic programming for any problem from today onwards, please remember you have to identify first of all any repetition there or not there. If repetition there, don't apply. Repetition, right? If repetition there, apply. Repetition not there, don't apply because space waste. Some people are asking greedy and dynamic programming. Greedy is greedy. You don't bother. Greedy is greedy. You don't bother. Correct, right answer or wrong answer. Greedy another name is shortcut. Greedy another name is shortcut. So you have to use a lot of brain. In the case of the greedy, lot of brain you have to use because getting shortcut is very difficult. Right? If you take any problem, who knows what is the shortcut? Right? Greedy problem is, it is a shortcut. Very less people will get the shortcut. Most of the problem, 95% problem don't have shortcut. But 95% people, right, may repeat. Very less people don't repeat, but 95% of the problem will repeat. So 95% of the problems you can apply DP, 5% of the problem you can apply, right, greedy. Greedy is a shortcut. Finding shortcut for every problem very difficult. Yeah, anyone having any doubt? Sir, I have this doubt. You ask me, I will help you. Sir, I have this doubt. You ask me, I will help you. Those people who want to join in Unacademy, my sincere suggestion, join as soon as possible. Join as soon as possible. If you are really serious about GATE exam, you can join. You can join. Algo DS is going on. Evening computer network is going on. Right? Some other teachers are teaching some other subjects. So what I want to say is, Unacademy is the best one if you determined. If you determine, I want to get a very good rank, Unacademy is the best one. Right? Unacademy is the best one because recording is there, live also there. Practice classes are there, what you want. Practice classes are there, recording is there, live is there, test series is there. Right? They will provide books also, everything is there. What else you want? The only thing is, dedicate some time, prepare properly, do lot of hard work. Don't buy hard the things, but don't delay from now onwards. At least take decision today. Take decision today and join from today. Join tomorrow onwards. You can attend the classes. I hope this class is really useful to you. I hope this class is really useful to you. Right? So I think we can meet in the next class. Any doubts are there before going to end up this class? Please let me know. GATE exam follow the DP. Exactly Ashish. Exactly Ashish. What a nice line. In GATE examination, same question will not be given again. In GATE examination, right, same question cannot be given again. What a nice line. Cute boy. University exam follow greedy approach. So I am not happy with this line, but right, but that is true. GATE exam follows DP. GATE exam follows DP. Our life is DP. To be frank, our life is DP. All humans are, most of the humans are greedy. They don't see what are the consequences. They are greedy. Humans are greedy. University people have their own rules. Own rules. Maybe. So, those people who don't know dynamic programming, please see this one time, because see 1 hour whatever possible I explained. Actually dynamic programming in the plus class I explained approximately 15 hours. Dynamic programming in the plus class I explained approximately 15 hours. I explained 8 applications I explained. Dynamic programming in the plus class I explained 8 applications. So, if you attend the 8 applications you will get the clarity, right. So, 1 hour, at 1 hour what I can explain, right, whatever possible I done that. So, I think this class is really useful to you. Those people who are not getting, maybe some dots you are missing, right. What you exactly have to do is you have to connect some dots. Some dots are missing, some basics are missing, you have to connect them. Right. So, thank you so much everyone. Good night. See you in the next class. Thank you so much. Our politicians are greedy. Yes. Our people also greedy. Ashish, people also greedy. Ashish. Good night.